Hello everyone, welcome to my channel Precision Manufacturing System. I'm coming back with a new practical project. Today I'm going to talk about jump cycle for performing wear simulation using UMESHMOTION subroutine. Before doing anything, please subscribe my channel and also click like to increase my motivation to prepare more practical video for you. In my previous video about wear simulation, I discussed how to prepare your own UMESHMOTION subroutine for performing a wear simulation. I explain about Archer model for my UMESHMOTION subroutine. As you know, for defining Archer model in your UMESHMOTION subroutine, you need define CPRESS, C-sleep, and also wear coefficient using utility routines like getWhen. And also I explain about how to match UMESHMOTION subroutine and ALE adaptive mesh to update the node position in your simulation. So I need to explain about jump cycle, why we use jump cycle in our simulation. For example, you want to do a pin on disk wear simulation with 100,000 cycles. You can imagine if you want to do wear simulation with a high cycle, it maybe take long time. For example, you consider 100,000 cycle, and your pin want to rotate on disk until 100,000 cycles. So if you consider wear simulation cycle by cycle, it maybe take a long time, maybe 1 month or 2 weeks. So it's not reasonable to do wear simulation with this method because of the computational cost. So in this video I'm going to explain how to perform your wear simulation using UMESHMOTION subroutine and the jump cycle. I also explained this flowchart in my previous video. For performing a wear simulation using Archer model, you need define wear coefficient, CPRESS, and your sliding distance. And also this flowchart illustrate the wear simulation process using UMESHMOTION subroutine. For example, in your abacus CAE, you define geometry, material property, boundary condition, and contact. And for your user UMESHMOTION subroutine, you need to consider some utility routines, for example get one, and also obtain contact property, contact pressure, suppress, sliding distance. And also you need to define wear coefficient, the wear coefficient and acceleration factor, or delta n, or jump cycle, to help you to perform your wear simulation with less time than without jump cycle. And then consider archer model where and calculate the wear depth delta h equal delta n k p and delta s. Delta n jump cycle, wear coefficient, suppress, and sliding distance. After that, you update surface nodal position and use and also define adaptive mesh in your CAE and repeat this process. I open my UMESHMOTION subroutine. Okay. As I already explained about UMESHMOTION subroutine in my previous video, we define cpress, cshare, csleep, copen, dh, and kappa wear coefficient. For performing wear simulation with jump cycle, we need to define additional factor, as I explained already, delta n, or jump cycle or acceleration factor. So I add integer name delta n. And I need to mention, it's so important, delta n value. You cannot put every value for delta n, because it affect your delta h or wear depth. So first, it's necessary to examine some delta n, for example 1000, 2000, it depends on your simulation, and consider the result. If the result after determine delta n follow a same trend, so you can choose that special delta n for your wear simulation. So after defining integer delta n, in this place you need consider a value for your delta n. So for example, I consider 1000 in here, delta n equal 1000. Okay, and I also explain get part info and other thing in my UMESHMOTION subroutine in my previous video. You can find two video about word simulation. The first video I explain how to set up your CAE, and the second video explain how to prepare your your own UMESHMOTION subroutine. So I define delta n as a jump cycle in here. Now we need to multiply delta n in our Archer model equation. So define delta n, here. After that, you can use this UMESHMOTION subroutine in your world simulation and see the result with the with jump cycle and without jump cycle. I perform some simulation and show in some slide and also explain about the result of the using different various delta n in my UMESHMOTION subroutine. For example, I consider pin on disk simulation and element type for my disk or plate is C3D8, element size is 0.1, friction coefficient is 0.1, and I define surface to surface contact, and I use 100 Newton as a load for my simulation. First, I consider pin on this simulation with delta n 1000 delta n and perform simulation for different paths. Pass 1, pass 1 means 1000, pass 2 means 2000, 3 means 3000, 4000, 5000, because I use delta n 1000. And for the computational time, I consider 5000 cycle, and you can see computational time was 2 hours, and then I define delta n 500 and consider for 5000 cycle, and you can see time simulation time was 4 hours. And also for 250 the simulation time is 8 hours, closely to 9 hours. So you can see defining jump cycle is so important in world simulation, and decrease sharply your world simulation. But also, as I already explained, it's so important to perform your word simulation and consider various delta n to see the result. If you see a same trend, you can see that special delta n for your word simulation and decrease the computational time, and after that you would be able to examine more word simulation. Okay, you can see the result of word depth of my word simulation with different delta n for 5,000 cycles. You can see when I consider delta n 250, the word depth, especially in 5,000, the word depth is lower than for 500 and 1,000 delta n. And also you can see word depths for 1,500 after word depths after 500 is experience same trend. You can see word depths for 500 and 1,000 is similar. So for decreasing the computational time, I consider 1,000 for my simulation instead of using 500. I hope this video helped you to perform your word simulation with less time. Please subscribe my channel and also click like to increase my motivation for preparing more practical video for you. Enjoy your time. See you later.